Hi, good morning, everyone. So today we're going to go to the next topic. So we're going to use FTC, the fundamental theorem of calculus, to solve problems. So let's refresh our memory. If f of x is continuous on the closed interval from a to b, and this big f of x is an antiderivative of the f of x, then integral a to b small f of x dx equal to capital F of b minus capital F a. So this is the antiderivative. Let's take a look at another version. So we learned this version before. If g prime of x is continuous on the closed interval a to b, integral a to b g prime of x dx equal to g of b minus g of a. G is the antiderivative of g prime of x. We're going to use this theorem to solve problem. Let's take a look at question number 1. So question number 1 said g prime of x is the derivative of g of x. So g prime of x is a linear function. We know that there was g prime of x and the entire g of x. And we know g of 2 equal to 10. So we had to find the value of g of 4. So let's list the information. So we know the graph of g prime of x. And we know g of 2 equal to 10. And we need to find g of 4. Antiderivative of g prime of x. So we're going to use the FTC. So integral a to b g prime of x dx equal to g of b minus g of a. So we need to know what is a and b. So let's take a look at the x value over here. We get x equal 2, x equal 4. So now we know a is 2 and b is 4. Then we got integral 2 to 4 g prime of x dx equal to g of 4 minus g of 2. Let's take a look at this part over here. So we learned it before. We said that the integral represents the area underneath the curve. This integral would take the same answer as the area if the area is above the x-axis. So let's take a look at the integral from 2 to 4. Let's go back to the graph over here. So from 2 to 4, so this will be the area we're going to calculate. It is a trapezoid. So it means it equal to the area of the trapezoid. So integral 2 to 4 g prime of x dx equal to the area of the trapezoid, because it is above the x-axis. So now we're going to use the formula, which is going to be 1/2 times base 1 plus base 2 times the height. And we bring down the g of 4 minus g of 2. This equals this, g of 4 minus g of 2. Let's take a look at this part over here. So we know that this is going to be 2 units, and this is going to be 4 units. So we got base 1, and we got base 2. And this is going to be the height. So we got height equal 2. So we're going to substitute in here. We got 2 plus 4 times the height 2. And we have g of 2 equal 10. Let's simplify a little bit. So we got 2 plus 4 equals 6 equal to g of 4 minus 10. So at this moment, you already know the answer. We plus 10 both sides. So we got 16. So we found the answer using the FTC. So some people say, can I use another way to do it? because we know the graph, and then we can find the equation of the graph, which is the equation of g prime of x. So if we do this, we need to find the equation of g prime of x, then find antiderivative. I don't suggest you use this method, but it worked. So now let's find the equation of the g prime of x. So this is a linear function, so we can see that this 2, 2, 0, 0, and then you get 1, 2, and 1, 2. So therefore m equal to 1 and b equal to 0. So y equal to mx plus b, so y equal to x plus 0. So we get g prime of x equal to x. So after that, we're going to do the antiderivative. So we got x dx. The antiderivative of x equal to x squared over 2 plus c. So in other words, g of x equal to x squared over 2 plus c. But we still don't know what c equal to. This entire family had the derivative of x. So c, it could be any number. But since we know g of 2 equal to 10, so we're able to use the initial condition to find c. So we use g of 2 equal 10 to find c. So 2 comma 10, so we get 10 equal 2 squared over 2 plus c. 2 squares is 4, and then we're going to divide by 2. So we get 10 equal to 4 divided by 2 plus c. 10 equal to 2 plus c, and c equal to 8. So now we know that g of x equal to x squared over 2 plus 8. Now we use this equation to find g of 4. So g of 4 equal to 4 squared over 2 plus 8. And now we can figure it out. So we get 16 divided by 2, which is a. So a plus a equal to 16. So we get the same answer. This method is correct. You probably see it a lot in the physics class, but I don't suggest you use it in my class. You will find out FTC is much easier to use. Now let's take a look at question number 2. Question number 2. There's a graph given, which is g prime of x. G prime of x is the derivative of g of x. G of 3 equals 40. The area B enclosed by the graph of g prime of x and the x-axis is 6 square units. So this is 6 square units. We have to find the value of g of 7. So based on the questions, so we know that g of 3 equal to 40. We had to find g of 7. And we know g prime of x is given. So definitely you cannot find the equation of g prime of x. That's not enough information. But we can use the FTC. So now we're going to do integral a to b. Put the g prime of x dx inside. And then we had g of b minus g of a. Now let's figure out what's a and b. So we got 3 and 7. So we do substitution. We get integral 3 to 7 g prime of x dx. G of 7 minus g of 3. So we're going to use the same strategy. we're going to look at this integral, and it represents the area between the x-axis and the curve. In other words, area under the curve. And because this part is above the x-axis, so therefore it's equal to 6, equal to the area. So now we got 6 equal to g of 7 minus g of 3. And we know g of 3 is 40, so we put minus 40. And now we just add the 40 both sides. So we got g of 7 equal to 46. Now let's take a look at question number 3. Question number 3, we have the g prime of x is given. It says that the g prime of x is the derivative of the g of x. G of 4 equals 40. A, we have to find g of 0. And B, we have to find g of 6. So let's take a look at part A. So part A, we got g of 0 equal what? And g of 4 is given, which is 20. And we know g prime of x is given. And let's take a look at this. This is a semicircle. We're definitely not going to try to find the equation of the semicircle. We're going to use FTC and then use area. So we do integral. So this time we're going to skip a little step. So we got 0 to 4. So we put 0 to 4. We put the g prime of x dx equal entire derivative of g prime is g. So g of 4 minus g of 0. So this is the area of the semicircle. It's exactly equal to the area because it's above the x-axis. So we get 1/2 times pi times the radius squared, which is 2. And we know g of 4 is 20. And we have to find g of 0. So one more time, this equal to 1/2 pi times r squared because it is above the x-axis. So we calculate. So we got 4 divided by 2 times pi. So we got 2 pi equal to 20 minus g of 0. So at this moment, I believe everyone already know what to do. So we're going to solve for g of 0. So minus 20 both sides. So we got 2 pi minus 20 equal to negative g of 0. Divide the negative 1 both sides. So we get negative 2 pi plus 20 equal to g of 0. So some people may want to skip some steps. So over here we got 2 pi equal to 20 minus g of 0. We're going to move the g of 0 to the left side. There was a minus over here. When you move over, it becomes positive g of 0. You move from one side to the other side, it takes opposite side. Now we keep the 20, and you have a 2 pi on the left side, the equal side. You move it to the other side, it takes the opposite side. So we got 20 minus 2 pi, same as what we got before. Minus 2 pi plus 20. So we finished 3a. Now we're going to do 3b. Let's take a look at 3b. 3b, we had g of 6, that's defined. And we know g of 4 equal to 20. So same idea, we are going to use the FTC because we know g prime of x. So we're going to do integral a to b. So we're going to do 4 to 6 g prime of x, and then we're going to get dx equal. Antiderivative will be g, so g of 6 minus g of 4. So now we are going to look at this left side again. It always relates to the area underneath the curve. From 4 to 6, based on the graph, we got a triangle that's underneath. So if we calculate the area over here, it's going to be 1/2. You get 1, 2, and then you get 3. Simplify, so you get 3. So the area equal to 3. However, the integral will be negative of the area of the triangle. The reason is because it's below the x-axis. The area is always positive. The area is 3 itself. But the integral is going to be negative. So now we're going to put -3 equal to g of 6 minus 20 because g of 4 is 20. So at this moment, you know what to do. We just solve for g of 6. So we plus 20 both sides. And then we got g of 6 equal to 17.